Thank you for joining us today for Leveling Up, Extending Hyperconvergence Beyond Storage and Compute. This is a webinar brought to you by Stratascale and Actual Tech Media, and we're here today to talk about hyperconverged infrastructure. My name is Scott D. Lowe. I'm a co-founder of Actual Tech Media and a consultant, blogger, and author. I'm joined today by Jeff Margolis, Director of Pre-Sales Engineering for Stratascale. Jeff, thank you very much for being here with us today.
My pleasure as always. Thank you.
So what is this whole thing around hyperconvergence? What's happening that's leading people to this, pond of water that we're calling hyperconvergence from which people want to drink? Well, first of all, the data center has become a pretty complex place. When you look in the door, you look in the window, there's lots of blinking lights going around every piece of equipment, and who knows what they all do. Obviously, people do know what they all do, but it's still tough to manage. When new people come on board, it can take quite some time to come up to speed on what's happening in the data center, and in some cases, it's sort of become a very fragile environment. As a result, it's also become far too expensive. We have lots of different equipment from lots of different vendors, and that means we need lots of different people with lots of different skills to keep it all up. Now, that's a problem. We don't see very many organizations that want to have to grow their IT staff linearly. That is, as we add equipment, we don't want to have to add people. We want to be able to continue to do more or do with what we have, even while we add more equipment. Adding IT staff is often considered an expense function on the expense side of the house. We don't want to do that in business. We want to be able to add revenue drivers and keep overhead in the form of expenses as low as possible. And because of all this, in some ways, the data center has really become a chain that's binded IT and, as a result, the business. We have a lack of flexibility and agility in the modern data center. And the reason I say that is because of the reasons I just mentioned before. All of this complexity makes it really tough to change things because we have to be worried about what those second-order consequences are going to be when we actually make changes in the data center. This inhibits the flexibility that we have when we do need to make changes for the good of the business. And that means overall we're less agile as a function. It's really the very opposite of what IT is supposed to be. We're supposed to be enablers. We're supposed to be able to enable the business to continue to do more and to move forward in a way that doesn't hinder them. Unfortunately, we have kludged together solutions that don't always work well together. I hear stories all the time about vendor finger pointing. In fact, when I do speaking engagements, I ask the audience a lot, have you ever had vendor finger pointing take place? And everybody in the room chuckles because, yeah, they have. And it's really no fun, and it's not fair. We really buy these solutions so they're going to work for us. And it's not really fair when we get into a situation where the vendor A tells the vendor B that that's their problem, and you're left in the middle holding the bag. We also see a lack of policy alignment or focused differentiation on policies. And what I mean by that is if you think about storage and a WAN accelerator, for example, those act on very different constructs. Storage works on LUNs, and a WAN accelerator may work on a protocol. So when we're trying to align policies around VMs that run our applications, we have to try to think in very different ways depending on where a workload is moving around in the data center. We don't always have a way right now to really take a virtual machine or an application-centric approach to policy from start to finish across every aspect of a virtual machine's lifecycle. We also have basically incomplete integration between various systems. And so we sort of halfway integrated things, or even if we have integrated things, they don't always work the best. But it makes it very, very difficult to pinpoint problems and performance challenges. As a result, we buy all kinds of monitoring tools to try to help us delve deep into the data center dungeon and try to figure out what's going wrong. We want to understand why the ERP is slowing down when user X is running a certain report. But we're trying to figure out if that's at the database, if that's at the storage, if there's something happening with the virtual machine as far as virtual CPUs go, what have you. We have all kinds of different places to look and requires different skill sets and different tools to try to determine exactly what can be going wrong in the environment. We have incomplete resource control and insight, and we try to augment our already complex environments with third-party tools, basically monitoring tools, to try to help us with this stuff. So we spend yet more money to try to address overall complexity when what we really need to do is make the whole thing easier to manage. Further, the data center has really become a money pit. In fact, if you think about the way we've often purchased hardware or infrastructure in the data center, we go on a 3 to 5 year replacement cycle. 1 year we may do servers, the next year we may do storage, the next year we may do networking, whatever it happens to be, however you decided to structure your cycle. Most companies have some kind of an equipment life cycle. But we size all of our equipment out for the next 3 to 5 years. Now let's think about manufacturing. You wouldn't have the widget maker down the street try to build inventory for the next 3 to 5 years. And there's a number of reasons for that. The first reason is that it ties money up. The more you have in inventory, the more money that's sitting on the shelves waiting to be sold. The second reason is because needs change. People may decide they don't like the widget model 101, they like the 201 better. So you may end up with a whole bunch of 101 version widgets sitting on your shelf as people are demanding the 201 widgets. So you basically lost out on selling all of your version 101 equipment. Well, when we buy our data centers today, that's kind of what we're doing. We're buying today's technology to use tomorrow. And if you look at the graph that's on the screen right now, you'll see a red zone. I call that the zero return on investment zone. For the next 3 to 5 years, we have a huge red space. The black line on the screen is actually how much data center performance and functionality we need today. The blue line is what we actually bought. So as you can see in year 1, we have a huge gap. That means we're not getting the bang for our buck that we would expect, the return on investment from that data center purchase. By year 4, we've hit that limit. We've hit the level what we need. But then we need more. We have to be able to get a little bit more in year 4 because the business grew. Basically, it requires constant expansion and attention, and we don't always have ways to best understand exactly how we need to scale the environment. So this is the approach we take. We buy for 3 to 5 years and then hope for the best. In our traditional data center, we have lots of servers with lots of storage. The servers in this diagram are on the left, and the storage is on the right-hand side of the diagram with some networking in the middle. As we need more, we add more of each resource, but we don't always have ways to determine exactly what's going to be the best approach to adding resources. Now, let's talk about hyperconverged infrastructure. We see hyperconvergence as a way to combine disparate data center resources into fewer components that are simpler to manage. At its most basic, hyperconvergence is a conglomeration of compute, storage, and simplified management. It's really the beginnings of a shared resource pool, and it's a beginning to the end of the hamster wheel upgrade cycle. So when you think about being able to go with a common Lego-like brick to be able to expand your data center, as you need more, you just add more bricks. And as the old ones get too old, you just take them off the board. You don't have to worry about moving all your data and about downtime, even when you have to scale or when you have to remove equipment. It's basically a simplified approach to the data center that makes management far easier and allows scale and economics to really be one and the same. The technology that underlies hyperconverged infrastructure has really taken hold with these roots, and it's growing into a significant tree of opportunity for a lot of organizations today. So rather than that mess we had before, we basically take networking and a hypervisor and we put it on a compute and storage node now. We take all the storage that used to be in a SAN. Hyperconverged infrastructure eliminates the SAN. That's pretty key to a lot of organizations. It's one of the most expensive things that we buy and one of the most challenging items to maintain in the data center. We take all that storage from the SAN and we distribute it across nodes in a cluster. And as you can see in the diagram on the screen, we have 6 nodes, each with disks. These happen to be hosts. These, in this case, are VMware hosts. So we have vSphere loaded on these nodes, and we have a virtual storage appliance, which is just a virtual machine, managing all the local storage, and all of these nodes are combined together with Ethernet connected to a switch. Now you also see that we have networking sort of separate there. In the case of many hyperconverged infrastructure solutions on the market today, we don't do a great job. We don't see them doing a great job yet with including the networking resource, but that's all about the change, as you'll learn later on in this broadcast. So what makes storage tick in the world of hyperconvergence? Well, the key is software-defined storage technologies. And if you look at the diagram on your screen, you can see that at the very bottom we have lots of storage. This is a combination of flash disks and spinning disks. There's an arrow pointing to what's called a VSA. That's a virtual storage appliance. That's a virtual machine running alongside all the other business workloads that's responsible for managing all of the storage that's local on that particular node. All the VSAs in the cluster talk to one another, so they basically create a single shared storage pool in a global namespace. So each VSA knows what's happening on the other nodes, and it presents back to the individual nodes in the cluster a single shared storage pool that the storage administrator no longer has to actively manage. But the key here is to notice that we're also carving out VMs from this shared storage pool. So the very disks that the VSA is managing are being reused by other virtual machines that sit alongside the VSA. So what are the outcomes that we're expecting to see from hyperconverged infrastructure? First of all, we see simplified procurement. When you think about how you have to buy a data center today, we have to go buy all the individual component parts, size them, make them work together, and then hope that they're going to stay working together. We also get simplified deployment for the same reasons. If we think about our typical deployment, we have to make it all work. We have to cable it all up. We have to do cyber channel. We have to have a storage environment, a storage infrastructure, and it can get pretty complex. When we think about hyperconverged infrastructure, we start to see that we just have to have 10 gig Ethernet available or 40 gig Ethernet, in some cases even just gigabit Ethernet. We connect the nodes to the Ethernet network, and that's it. That's the deployment process. That's the racking part. From there, it's all software. We also get simplified operations. So we're making things easier to manage. We're able to, rather than have to separately manage storage and networking and the hypervisor and all that good stuff, we're able to just manage the items that happen to be included in the hyperconverged infrastructure. We have a VM-centric view of the world. We actually understand, to a deep level, depending on the solution, exactly how a particular workload is operating. So we can understand its impact on storage, we can understand its impact on networking, and more importantly, we start to have an opportunity for the hyperconverged infrastructure to begin to actively allocate resources to make sure those workloads run the way they're supposed to. And you'll learn more about that shortly. We also have an opportunity to simplify scalability. When we have to scale now, we either have to scale because we have to add more IOPS, we have to add more capacity, or we need more CPU or more RAM. With hyperconverged infrastructure, we take the complexity out of scale because we often have to also schedule downtime when we want to scale environments. With hyperconvergence, we simply add another node, and after that, the environment simply consumes the resources from that node and assimilates it into the existing resource pools that already exist in the hyperconverged infrastructure. And of course, just like every other solution on the market, there's other benefits that can be had. These are all vendor dependent, and you're going to learn about one such solution in just a few minutes. So I've talked about hyperconvergence being sort of maybe a silver bullet, but it's not always the case. When we think about hyperconvergence, there are some missing pieces. First of all, the hypervisor itself. This can be an expensive challenge. And if you look at a lot of the hyperconverged solutions on the market today, they support things like VMware and Hyper-V. Well, when you think about it, no one owns that except Microsoft and VMware. So you're sort of at their mercy. If you actually had a solution where the vendor owned the hypervisor, really cool things can happen. We have the ability to get much deeper into the infrastructure than we otherwise could because we can't get as deep as we want to with vSphere and Hyper-V. We have no control, no direct control of the hypervisor that's from a third-party vendor. Of course, there's some exceptions here and there, but for the most part, we have a big challenge with the hypervisor. The leading hypervisors are on the market today. They're closed systems that we sort of have to live with and hope the vendor doesn't do something crazy that breaks our environment with the next release. Networking is also a challenge in many hyperconverged systems. And the reason for that is because we remain reliant on hypervisor-based networking constructs or even physical constructs that are already in our data center. Basically, we remain subject to decisions made by other vendors. We don't like that. It impacts our overall manageability and policy controls because it's a resource that we can't directly control with a lot of hyperconverged systems that are on the market today. So what it comes down to is that without full workload and resource control, it's more difficult to establish a secure multi-tenant environment, and we can't always provide complete real workload isolation. It becomes a big challenge, and it becomes a security issue for many organizations. We also end up with situations where we have to bolt on components that we don't end up getting the full seamless experience that we really need to be starting to get from the data center. The data center needs to be thought of as plumbing and invisible to a lot of organizations moving forward. That's the piece that we need to fix when it comes to hyperconverged infrastructure. We also want to see hardware heterogeneity. We want to be able to add resources as we need them. We don't want to be at someone else's mercy. And when we talk about hardware heterogeneity, if we've already got relationships with hardware vendors, why mess up a good thing? We should be able to use whatever kind of hardware we want within reason in a way that enables our business and not in a way that we have our hands tied. We want to be able to think about adopting a just-in-time methodology for our data center as well, just like manufacturing. If we can move to a just-in-time data center, we can vastly improve the economics behind the entire IT equation. We want real hardware commoditization. We don't want to have to spend an arm and a leg on hardware that we simply don't need. We also want to see equal support for some emerging constructs that are coming on the market. For example, containers and even OpenStack. When we think about virtual machines, those are pretty easy to deal with in a hyperconverged scenario because lots of vendors do that. We get traditional workloads with hardware emulation. Well, containers are sort of the new kid on the block today, and they're going to start to become more pervasive, just like virtualization did last decade. This is a situation where we have shared binaries and much less overhead, meaning we can get more workload density on each system. And then we have the open nature of OpenStack, which helps us to eliminate proprietary components and improve overall data center operations. We need to have hyperconverged solutions that can support all of these things so that we can do business on our terms and not someone else's. This is what we want to see. We want to see the networking, the hypervisor, and storage all in one pretty node, all connected together with just basically Ethernet. And I'd like to turn it over to Jeff Margolis from Stratascale to continue on with the presentation. Take it away, Jeff.
Excellent. Thanks a lot, Scott. So you touched on a couple of very interesting points here, and I think I'd like to reiterate that as I'm going along in my deck here. So what is Stratoscale providing? There's a couple of different slides right here that I want to show you from a high-level point of view and then sort of dig into it. So when you're buying virtualization today, it seems to be separated through various components. So you virtualized your workloads, but you still have networking separated, fiber channel storage separated. And as you said, when you're buying something, you're sort of like buying in advance or holding inventory in advance or whatever. And it seems like, yeah, I buy this huge fiber channel SAN and it's got, terabytes or even petabytes if I'm still lucky in terms of the amount of storage that I have, but I'm not utilizing that. So I'm buying a lot of infrastructure in advance rather than buying just in time, which we've seen just in time in manufacturing and whatnot that has made companies a lot more efficient in manufacturing and consumption and so forth. And what Stratascale is doing is very similar to this kind of just-in-time concept. So if I take a server that comes from Cisco or a white box from Intel, HP, Lenovo, an old IBM server, Dell, whatever the OEM is of your choice, what you can do is take all of these servers and put them into a single Stratascale cluster, and we're utilizing all of the resources internal to the cluster to provide you sort of a virtualization or even more importantly or more apropos, a cloud environment that will be able to be grown or will able to be stretched out or be elastic as the community uses in discrete fashions. So we're hosting virtual machines and containers in the same infrastructure. We have our own high-performance storage that's based on internal disk to the servers themselves that you're using. And we have a lot of intelligent resource management. And this isn't just a couple of buzzwords we're throwing up there, but we're actually profiling all of the servers and the workloads that come into the cluster, both virtual and physical hardware. We're profiling those and putting workloads that are more intense on newer, more intense, capable servers. And we're taking workloads that are probably not doing as much. As an example I use with customers is, let's say I have an Active Directory and LDAP server that's being used once every 20 or 30 seconds for login information or authentication or authorization, of course. I can put that on an older server. And this is another sort of benefit that Stratoscale brings, is that any server that is Sandy Bridge and newer x86 can be put into the same cluster as a brand new Haswell, Broadwell, Ivy Bridge, whatever, anything newer than Sandy Bridge can be put into the same cluster. So this is some of our intelligent resource management. So again, sort of summarizing this first slide is that bring your own hardware to host virtual machines and containers. They can be different sizes and shapes, blades, 1U, 2U, 4U servers, quads, twins, whatever you'd like, and different vendors, HP, Dell, Supermicro, Cisco, Lenovo, IBM, whatever you want, put these all into the same cluster, and we're going to pool these together and give you very large clusters with very high performance storage based on what you have internal to this system. So I designed this slide to give you a very specific understanding what our 5 pillars are from a technological point of view, the value proposition from a technological point of view. We're doing a hyperconverged software distribution that is based completely on our own product. So we're delivering you an installer that has the operating system based on Linux, OpenStack, KVM, and then a lot of our intellectual property that is on top of this. So you're not laying down a Red Hat or an Ubuntu or a Windows or a VMware and then putting us on top. We have the entire software distribution that we're giving to you, and you can mix and match all of your hardware. And Sandy Bridge new Intel processors are newer, so that means that you can have Sandy Bridge, Ivy Bridge, Broadwell, Haswell, and whatever the next new processors are that come from Intel. You can put those all into the same cluster and bring your own and mix and match them. And I think I've said that a few times now. The real-time load balancing. So we have this intelligent workload balancing where we know what nodes are overloaded, what nodes are not overloaded, and when we want to put workloads in different parts of the cluster, we profile the hardware, as I said a few minutes ago, and we put stronger workloads on newer servers and weaker or less taxing workloads on older servers. And our migrations, so these are called vMotion or live migration or whatever in other hypervisors. Our live migrations will work 100% of the time. They do not fail. Most of the time in other hypervisor technologies, the live migrations will fail if there's too much dirtying of memory and they won't converge. Ours will work 100% of the time, and we can do it in a second to half a second in terms of moving a VM or a container from source to destination in about half a second on average. We have a distributed high-performance block storage protocol. We call this Mancala. That is the sort of code name for the product, the software portion of the storage product. It's software-defined block storage, and we're utilizing all of the disks inside the server to act as a cluster-wide SAN. So, for example, if I have 10 servers with 10 disks, I have 100 disks that are inside my block storage device, and we have tiering and various capabilities for thin provisioning and so on and so forth in terms of the storage protocol. We have a single fully distributed management plane, and what this means is that you don't have a single VM or a single server that is your vCenter or system center or manager that is sort of a single point of failure. Yes, there's high availability built into some of those, but we take all of the processes that are required to run the cluster and we spread them out across the cluster, and they're always running with state databases to make sure that every process knows what is required to run that particular function of the cluster. So you can lose half your cluster at a power outage or even a planned outage, and your cluster still runs with no management distribution issues whatsoever. And then we also have a lot of interest from the DevOps community to work with us because of our very, very nice feature-rich and API-driven control plane. What this means is that you can launch workloads, storage volumes, networks, users, tenants, all these different features through our various APIs. We have our own private API, and I don't mean private as in when you're talking about developing using private versus public, but meaning it's a Stratoscale-based API. And then OpenStack APIs will be available very soon, if they're not already, depending on when you're listening to this or watching this or whatever. And lastly, we'll add some Amazon EC2 and S3 APIs so that if you're bursting out to Amazon, you can use the same APIs on our cluster as you can with Amazon. Or if you're forklifting all of your external workloads from Amazon and bringing them into your private cloud, as many customers are, then you can continue to use the same sort of scripting and applications that are leveraging those APIs within our system. So again, when we're talking about sort of the old world versus the new world, when we're talking about what Stratoscale is providing, what we've seen a lot when we're talking to our customers and when we're talking to CIOs and so forth, and I wrote a very interesting blog on stratoscale.com/blog around the same concept, is that older virtualization, or what I call legacy virtualization, was used for traditional applications that were supposed to be highly available and very reliable. We were trying to consolidate to get price performance, and very plan-driven and long life cycles. So what this means is that I'm using very nice systems that are very expensive, but they're very nicely available. So an EMC SAN doesn't go down. They're very strong in terms of what they've developed over the years from EMC. So the systems that they've provided are very apt and capable and highly available. So what this basically states, though, is that it takes forever to launch even just one VM or one physical server. Can take weeks to order, or even if I just go through my IT governance or IT planning or whatever, and I want to launch 50 VMs, this could take 6 weeks to 6 months, depending on the company that you work for. Some of my banking customers have said to me that it could take forever because you have to file a case and it has to get reviewed, and then this person has to find the time, and so on and so forth. And in the DevOps world, for the next generation applications that, again, are very reliable and they're very agile, and we're trying to provide customer experiences to computers and tablets and phones and even watches and whatever else is being connected today, we have to give the customers all of their capabilities from the application point of view that they are demanding today. So it's a continuous process where we're constantly updating code and constantly giving new versions. If you look at your phone operating system, whether it be Android or Windows Phone or iPhone or whatever, is that you're seeing upgrades daily to all of your different applications. And this is the kind of agility that from a vendor or a company point of view, we have to constantly be building new applications, and we need to get testing and load balance testing and load testing and code testing, all these testing, all this development. We have to get this down from weeks and months down to days, maybe even hours. So Stratascale is providing a very nice API that allows a vendor or a user or a developer or a customer in a service provider environment to use a single API to deploy things very rapidly. So we're not filing cases and waiting forever for something to be built up. We're doing these very quickly from a development point of view. So I can write code using REST APIs or any kind of development platform that I want into a Stratascale cluster and deploy hundreds of VMs, even if it's just for an hour of testing, and then tear them down just as quickly. So where are you today? This is a question that we have for all of our customers. Are you sort of in this standardization and you're looking to lower your cost, maybe reduce complexity and increase some performance because you have one application per server and it's too many servers out there? Are you getting into the consolidation, or are you moving towards a virtualization, automation, and orchestration? So Stratascale is really playing in this effectiveness over time sort of journey and providing orchestration, automation, and virtualization all into a single, very simple to install cloud platform. So the key words when we're talking to our customers, they're looking for cloud infrastructure, they're looking for a software-defined data center. Yes, these are buzzwords, but the point is that when you want to get into building your own internal cloud because you have issues with putting your very sensitive data out on an Amazon or a Rackspace or any of the big providers, you want to build your own cloud infrastructure, trying to stand up an OpenStack environment is not very simple. You want to have cloud, meaning you want to deploy VMs through a simple script, or you want to rapidly spin up infrastructure as the demand comes around the holiday season, or whatever you want to do. You want this all to be defined by software. So you don't want to go to your switch and configure your switch, and go to your virtualization and configure this, and go to your storage and configure this. So it's too many discrete components that have to be constantly deployed and updated and upgraded and so forth. You want to go to a single place, write a simple line of code, and blast out all of your infrastructure in a single sort of script or application, and you need the cloud to be able to bring up tons of VMs and infrastructure and containers, because your developers want containers for simple deployment of applications and so on and so forth. This is what Stratoscale is providing for you today. So is your data center rack converged? Are you using sort of like, oh, I've got a switch here and I've got storage here and a server here, or are you using full hyperconvergence? And the benefit is that everything is going to be sort of scaling at a Moore's law level. So you're not just discretely adding another HBA or another LUN or another disk or another switch. You're adding an entire rack of new servers, or even just another disk, just to get a little bit more capacity inside of your cluster. So how good is the convergence or integration? Today, you're going to be working with Stratoscale. You're going to take compute, network, and storage, and you're going to put them all in the same device. It becomes very simple to work with your clusters. It gets very simple to deploy everything, and your IT operations, from the point of view of deploying anything that they need to deploy, is rack, stack, install, and ready to go. So we're putting all the compute, all the network, all the storage. It's not a single vendor solution necessarily, because you're not getting the bundling of disparate technologies. You're not getting a hardware or software silo. You're not getting competing resources. You're reducing your path of access, and you're getting a unified management stack. So how are the resources going to be managed? We're doing resource disaggregation, real-time physical resource and workload usage awareness. Like I said, we're putting things where they belong, sort of like taking this toy and putting it in that cubbyhole, or putting this system into that place, or putting this workload, and so on and so forth. This is very intelligent. We're constantly profiling what's happening to every disk, every network, every server, every piece of RAM that's going throughout the network. So we get this really good view of what's happening. This is a specific VM that I have launched inside my cluster. I can see that the red memory picture you see in this graph, the red is what's showing me memory going through the CPU at this moment. Yellow memory that's not being used. This sort of teal memory that has been evicted. So memory that is not being utilized at this particular moment can be evicted off, even though the operating system hasn't chosen to page it off. And the sort of darker blue color is that we're not going to give the VM all of the memory that it's asked for until it's being asked for. So this is another example of memory management that we're going to be doing inside of a Stratoscale cluster that gives you very discrete control over your memory utilization. So this is where hyperconvergence meets hyperintelligence. This is where hyperconverged core components mean dynamic cluster management based on Council, which is our cluster technology, fine-tune and storage-aware KVM hypervisor. Components of OpenStack, again, hardened and fine-tuned, our own distributed block storage device, a hardened Linux operating system, a very nice user interface that doesn't require a thick installer, that can only run on a Windows desktop but can run on tablets, Linux, Windows, Mac, anything, phone. We have a command line interface. It's very simple to use, a RESTful API, and relevant OpenStack binding and API support. So again, how are we very intelligent? We're doing workload placement. This essentially states that the VM performance awareness through real-time and historical workload trending, granular cluster state awareness, so memory usage, deduplication ratio for CPU and I/O, and then smart balancing logic, so the bandwidth management between management data plane for isolation efficiency, and we're dynamically allocating all the bandwidth based on customizable priority and service level agreements. So the traditional software-defined plus hypervisor versus OpenStack, we have no compromises. We're giving everything that is going to be available in terms of OpenStack, and giving a very strong system that spans the entire market. So we are delivering a vertically integrated software stack. It's a single distributed cluster, and we're lowering the total cost of ownership because, again, you can use old hardware with new hardware. Our operating system is fully deployed to allow every node to participate in every function: storage, compute, networking, management, and so forth. So you don't have to burn all of these CPU cycles for just doing a management server that's not doing anything else, and so on and so forth. So it's true hyperconvergence, bring your own hardware. We're utilizing all the resources inside the server, and it's a single installer for every node. And you're no longer limited to 32 or 64 nodes as you see in other virtualization technologies. We can have Stratoscale clusters that grow to hundreds or even thousands of nodes. Again, our management plane is fully distributed, so you could lose half your cluster by planned or unplanned outages, and everything still functions very nicely. Our APIs, again, Stratascale APIs, Docker API for containers, OpenStack APIs, EC2 and S3 APIs, and we have a very nice API Explorer that allows you to test out copy and paste code directly into your applications. And then, Scott, I will turn it back to you. Thank you.
Thank you very much, Jeff, and thank you all for joining us today.